Hi, my name is Mads Barnkop from Kaizer Power Electronics, and today I would like to do a big special teardown of a General Electric mobile X-ray unit. I think this comes from a local hospital, mostly due to the fact that it's thrown out here in the city, but also when I have been at the hospital, I have noticed these big power outlets that fits quite nicely with this unit. It is a very old unit, I would say. It's this one. It's the AMX-II mobile X-ray unit. I will give a more detailed rundown of which parts of this unit that I have and which we are going to look at and what we are going to analyze on this circuit. So let's first take a look at the parts and the small documentation I have, and let's get going. This is the complete unit as it would look at the hospital. It consists of a self-driving motorized mechanism at the bottom. Then it has a cabinet housing for the high voltage transformer and a battery pack. Then there is the control front panel and driver circuit. And then there is the X-ray tube unit and collimator. Over here is the vertical column where you can swing the whole X-ray tube unit out, and you can adjust the height of the X-ray unit according to the patient. Now if we take a look at a breakdown here of the unit, we can see that we have the battery pack down here at the bottom to keep the weight or the center of the weight very low for the unit. Now what I have is the high voltage transformer. I got the motor drive board, and I got the whole X-ray control unit, and that's about it. The rest of the unit was badly damaged, and the head was completely missing. So those things had been taken away before it was thrown out. The same with the battery pack, which we can see a picture of here. These are nickel cadmium batteries. Actually, while this is from 1979, it's a 120 volt DC battery pack. It is the same kind of nickel cadmium batteries that you would find in a apparatus from today, modern times. But this is how the battery pack would look, and that's all I have to show for it. It's a 30 cell battery pack, so each cell is 4 volts. But we will take a look at how this battery pack is used in the X-ray inverter and such. The X-ray high voltage transformer is this one. As you can see at the size compared to my hand, this is a quite heavy transformer. This is a 110 kilovolt, 300 milliamp peak transformer. Here on the side it has different inputs and outputs. At first we have P1 and P2, which are the primary inputs. Then there is G for ground. Then we have milliamp minus and plus for the milliamp measurements. Then there is XS1, XS2 and X common. These are for the 2 strings to measure the peak voltage on each string, as this is midpoint grounded. Also says down here, equipped with federal standard shockproof cable receptacles. So now if we look at the other side of the transformer, we can see over here the anode and cathode connections. And this is a standard shockproof connector. It's quite deep and has 3 small brass sockets. And if we can see the date here, it's August 1988. So the transformer here is roughly 9 years earlier than, or not earlier, but younger than the control panel itself. I will not take this apart, as this is full of transformer oil, so that's quite a mess. But I was lucky to find some transformer units that already had been taken apart, oil drained from them, and I took all the parts from there. These are parts from 2 transformers, so each of these diode modules consists of 84 diodes, so there are 42 diodes per string, and each string is rated for 75 kilovolt peak maximum. So these are roughly, what will that make? If it's 110, then it's 55 per string, so these are maybe rated for 40 kilovolt peak each, so it's 80 kilovolt rating for a 55 kilovolt actual supply. And as we can see here on some of the connectors, it's rated for 75 kilovolt peak. So these diode modules are quite nice. I'm happy to have gotten those from the MT transformers, and as well as 2 complete sets of connectors. There's of course a little issue with the cable here, but for hobby use, that's fine by me. This is the control panel itself. Over here on the this is the control panel and driver board and everything inside. Over here is the motor driver board. It's actually quite crude when you think about it. That there is a little controller PWM board. There's a power supply. There's a relay. There's some fuses. But then there are 4 huge power resistors, and these are actually to control the speed of the unit. So it's just putting a resistor more or less in series when it wanting to drive slow or fast. A little about the front here. It says here weight 370 kilograms, so that's the weight of the whole unit. So that's a good reason why it had some front bumpers and deadman switches. You didn't want 370 kilos going amok in a hospital. Now up here there's a key switch for on-off and for charge. There's an indicator for unit on. If it's charging, it's full charged. And then the battery condition meter is missing because these units have been rebuilt for main supply instead of battery supply. Here at the bottom there is a kilovolt peak selector switch. Goes from 50 to 110 kilovolt peak. There's a ready state status lamp. There's a XRAY active lamp. And then there's a battery normal and battery full switch. I'm not quite sure what that is. If the battery is full, that it has to throttle down a little bit. And over here there's a selector switch from 1 to 300 milliampere current. And then there's a huge warning down here at the bottom. Warning, this X-ray unit is dangerous to both patient and operator unless established safe exposure factors are observed. Read accompanying instructions. Sold to be used only by or the prescription of a licensed physician. Danger, explosion hazard. Do not use in the presence of flammable anesthetics. Do not recharge batteries in a confined or unvented area. So yeah, this is completely something you would want on a hospital. Another thing about this unit. There's a small manila mark here on the motor drive unit. It says May 18th, 1979. And that's also according to the date codes that we will find on capacitors and such inside the unit. But there was also a service notice that were a sticker here at the front. I have removed this, but it stated that the last service this unit had was in 2017. Now I happen to know a X-ray physician that works in Denmark, and I asked him about this unit and showed him some pictures of the control panel and such. And he said that for the 6-7 years that he's been working here, he has never seen this unit. So while it was serviced in 2017, it has not been used on patients at least for 6-7 years. So hopefully this has only been used on some school or maybe some animal hospital or something like that. Because it is extremely old for, yeah, just say that even medical safety, this is just... the age has caught up with it. So let's take a look inside. This unit is of course made from at a time where everything should be serviceable. So if we just remove the screw holding the whole front panel here, it opens just nicely. And everything is actually completely possible to exchange. There's a little bit of control here at the front, along with all the selector switches and the little board here. But the whole power inverter section and the controls up here is, and also along with the capacitors, is actually accessible. The only things that are hidden in behind are the huge power transformers and some relays and power resistors, and those are generally things that do not break. So we're going to take the overview drawing and look at that once again. See, we have another warning down here. It says, warning, 118 volts present at all times. Remove fuses 6F1, 6F2 and turn circuit breaker 6CB1 to off to disconnect this voltage. So that is highly likely the connector to the battery bank. Let's start up here at the control panel. Okay, there's some loose board here. Ah, that's quite nice. This is actually a board used by the service engineer. That if you had to actually measure on a board, you could just use this extension board. If it fits in here, like that. And then reinsert that. Yeah, that's a nice feature. Actually, I have not seen this before in normal rack-mounted unit, that there was a service card with the unit itself. That's quite nice. So at first here, according to the plan here, there is the first card here is the timer and overload card. So this has this little neon tube is broken. That's a shame. But this timer and overload card, yeah, that's probably a surveillance of the X-ray unit itself. Then there is a card 2. Here it says the filament and milliampere regulator. So this drives the filament supply and also the regulation from the front selector switch here, which actually just is a series connection of resistors. So depending on this resistance, this board determines the current that is driven out into the X-ray tube. Then card 3 says 500 Hertz inverter driver. This is the inverter driver for the main inverter, which for the high voltage transformer, which is driven at 500 Hertz. Now this is probably inspired by the aviation industry, where you generally use 400 Hertz just to lessen the weight of transformers and the wiring and such. That this was a mobile unit made at a time where mobility wasn't really that easy to make. So driving this at 500 Hertz makes sense to be able to build it smaller. And card 4 here, this is time delay board. So that is generally 4 relays and then 4 timing circuits. Just a single pot meter here, so only one of them is adjustable. So this is probably timing of the X-ray exposure and such. So these are generally something that you would have a lot of safeguards on and surveillance. Do you overexposure a patient and such? So yeah, while these has probably worked and were of course all checked by the governments and such, seems a little crude when you're thinking about today's standards and such. But as you can see, there is no programmable parts here. It's all analog technology. And then at last here we have a, see, that's board 3.5, which is the pulse board. Inverter Driver pulse board. So maybe this is the last output card to generate pulses for the SCRs that the inverter consists of. Then there is board 4A1 battery charge board. Ah, that's the one sitting here at the front. That's the battery charge board. That's also yeah, pretty crude. Things sorted over each other. There's a little heat damage here. There's a regulator sitting with a heatsink on the back. Other than that, we have yeah, over here there is the there's two inverters in this. There is a 60 Hertz inverter, which is yeah, quite fun, because that's the card 5. That's not the pulse bar. That would be 3A6. This is 3A5. This is the 60 Hertz inverter pulse board. Because since this is a battery-driven unit, but despite it comes from America, which is 120 volt country, then they have a built-in 60 Hertz inverter to generate a AC voltage according to what would be at the main supply in the US. So 2 of these SCRs are actually the 60 Hertz mains inverter, and another 2 are the 2 or 4 is the big X-ray inverter drivers. And as we can see down here, there's this huge selector switch for the huge selector switch for the kilovolt peak. Is actually just running back into a huge transformer sitting in here at the back. So that's probably just running through a tapped transformer. So yeah, that's actually yeah, you can say clever. But back when you only had SCRs and you could drive them in a certain way, it's not that quite nice a square wave or something like that you drive them with. You actually had to dump the pulses of this DC voltage from the bank into from a square wave and into the a step or step down transformer. So the selection you make on this kilovolt peak switch actually goes through a step up transformer, which then goes to the primary of the high voltage transformer. So that's how you select between 50 and 110 kilovolt peak. Then the inverter just short circuits the battery bank into that step up transformer. Along with that, we have the probably filament transformer sitting down here. And then there is just a lot of routing of different signals and such from yeah, all kind of sensors and the bumper sensors, the brakes, the remote control, etc. that were around and on this unit. There's various relays, capacitors, some other pulse driving boards over here. That's actually, yeah, that's the gate driver boards for the SCRs we have sitting over here. Not much to see on it. It has some pulse transformers and capacitors. There's some small snubber capacitors sitting here. But other than that, this is a pretty crude unit. It's low tech. It's all analog. But actually, not that bad. It's good looking craftsmanship. It's nothing really that special or funky about it. I really like this little slotted control computer here. So those are some nice analog boards. Now the inverter over here, I looked up these SCRs. These are 500 volt and then they were rated between 50 to 100 ampere peak. So those are quite nice, or not 100 ampere peak, but I think it was 100 ampere continuous conduction. And Yeah, over here there's a few two large power resistors, which actually are sitting in series with the primary for the high voltage transformer. So the high voltage transformer is actually being driven through two resistors here. So that must be some kind of current limiting or something like that. Yeah, but other than that, there's yeah, I can go handheld with the camera, and we can take a closer look at some of the parts. With a close-up of the inverter here, we can see the gate pulse driver board for the goes over here to the gates and cathode connections. And you see that these two are being run separately, while these four down here are the high voltage transformer. And this is really a dirty unit. That's full of crap in there. It's also kind of rusty. I had two of these units, and this is clearly the most dirty and an old one. The other one was in better shape, but it was completely destroyed from being thrown out. Now over here is a huge panel just for wiring all kinds of stuff that goes out the back of the unit. You can see this has just been cut off, but it goes in here and actually wires up behind to the control boards, which has the bus connections down here at the bottom. You see over here at the side is some of those power resistors and diodes and capacitors. There's just stuff put it in everywhere where you can find space for it. And there's also a buzzer here. I'm not quite sure what the voltage it runs on, but let's find out what the kind of noise it makes. Might be a easily recognizable nice buzzing sound that you would think, okay, something is dangerous now. Then over here behind the board, the inverter boards, there's some large oil-filled capacitors. So these are probably a some kind of DC bus smoothing. And another power resistor and a contactor in there. But other than that, then there's really only SCRs here and power resistors that is worth saving. Everything is just old, corroded, and just for being sold as a scrap metal and scrap cable. Okay, so I just discovered a little funny thing. I did mention that this had been rebuilt as the battery and condition meter is gone, and there was this weird switch that said battery normal, battery full. Now if we look at the back here, okay, boards come flying, but if you look at the back of that switch, it's just been cut off. There is no wires attached to it. And what looks like have been attached to it is this extended wire here. And then there must be, yeah, seems to be another wire missing. But if we see where this is going, it's going to the battery charger board. So while this is clearly not running on a battery, we can see that there are some new connectors here. That all original connectors are just without insulation on. But then there are all these new plastic here, so they have been making some kind of modifications to this unit. Also, we can see over here the yellow plastic cable shoes here. They are not original either. So some modifications have been made to this unit to change it from running on battery to running on a full mains connection instead. On the back of this buzzer, it said there's not a voltage specified, but it had a plus and minus sign. So I thought this might be because it's supposed to run on DC. So this is a 24 volt DC, and please do turn down for your speakers now if you do not want to blow out your ears, because this is how it sounds. Yeah, that's nice. Thank you for watching. I hope you enjoyed this vintage teardown of this X-ray unit. And if you got any comments on anything you would like to look at closer for something like this, please do leave a comment, and I will see if we can take another run on this. So, until next time, see ya.